Welcome to AP Biology. Today I want to talk about cellular respiration, but I can't yet because we need to do some background information. So the background information today are redox reactions. That is short for oxidation, reduction, reactions. So in oxidation reduction reactions, electrons are moved around, and this is really what's happening in cellular respiration. And so we can't get into cellular respiration until we practice a little bit of redox. So how do we harvest energy from fuels? That's what we're doing in cellular respiration, right? You take glucose and you break it down to carbon dioxide. So large molecules are broken down to smaller ones. Starch is broken down to glucose, which is broken down to carbon dioxide, or proteins are broken down to amino acids, which are broken down to ammonia and carbon dioxide and water. So when you break bonds, you move electrons from one molecule to another, and those electrons carry energy with them. And so let's look at an example. Here's a reaction with a yellow blobby molecule and a blue one. And let's say the yellow one is giving an electron to the blue one. And let's just assume they start neutral. So we're just going to assume that these two molecules are neutral in the beginning. When this yellow one gives an electron to the blue one, it's given up an electron, right? It's less negative. So that one loses an electron. If one is losing it, the other one has to gain it. And so this one has lost an electron, which means it's lost a negative, which means it's not as negative, so it's positive. So this means that it's a positively charged ion, a cation. And then this one has gained the electron. So this little white part here means it's like missing, right? The orange part means it's got the electron. So this has an electron, which means it's got an extra negative, which means it's got a negative charge, right? Electrons are negative. And so this is an anion or a negatively charged ion. And just to remind you, this plus right here means that you have these two. You have this thingy and that thingy, right? It just means like plus, or you're adding them. Okay, so what I want you to know about electrons is that they're really energetic. So if you walk across the floor with maybe in the wintertime when it's really dry, with maybe socks on, and if you're walking across a carpet especially, and you touch someone else, sometimes you'll shock them. Has that ever happened to you? Hopefully it has, so you know what I mean. What's happening as you walk across the floor is the electrons from the rug are getting onto you, and you're becoming negatively charged. You're charging yourself. And then when you either touch a light switch or maybe touch another human, you discharge and you can feel it. It's a shock, right? And it kind of hurts a little bit. And that's really the same thing that's happening with lightning. So with lightning, it's just a static charge that's discharging. So the clouds are all mixing up, moving around, and the electrons are moving from one cloud to another. A whole bunch of them are being shorn off of one cloud and getting onto another cloud. And when the charges discharge, right? When the electrons move from the cloud to the ground, it's a big discharge. It's a really big static discharge, and it's really powerful. It can kill you. It can burn down a tree, right? So electrons are really, really energetic, and that's what I want you to remember as we go through these redox reactions. Thankfully, in cellular respiration, we have a whole bunch of little redox reactions that happen in these tiny little steps, so we're not burning anything down. Okay, so the energy from the electrons can be stored in another bond or released as heat or harvested to make ATP. So this one is gaining an electron, which means it's more negative, which means it's got reduced positivity. This one is getting reduced. And if one is getting reduced, the other one is getting oxidized. I'll define it for you in a minute. Oxidized. Okay, so chemical reactions that transfer electrons between reactants are called oxidation reduction reactions or redox reactions. I don't know why they don't call them ox-re because they always say oxidation reduction, but whatever. Okay, so here's an example of a redox reaction. So what we've got here is sodium, and it's got 11 protons, which means it's got 11 electrons too when it's neutral, and it usually will give up an electron and give it to the chloride ion. So it's giving up an electron, and when it gives up an electron, it's giving up a negative, so now it becomes positive, right? So this one lost an electron, right? It lost a negative, now it's more positive. This one, you can see, is getting more negative. That means it gained an electron. So if you're gaining an electron, you're gaining a negative, right? You are more negative, which means your positivity is reduced. So the chlorine has gotten reduced. The sodium is the opposite, so this is oxidized. And I'll tell you what that has to do with oxygen in a little while. Oxidized. All right. So the sodium becomes oxidized and the chlorine becomes reduced. So here's the definition finally. In reduction, a substance gains electrons. That's this one. In reduction, a substance gains electrons, gains negatives, or it's reduced, meaning the amount of positive is reduced. So I always define it as reduction in my head, and then I look for the oxidized as the other thing. So oxidized is something that loses an electron. So you can memorize. Here, let me just actually let me circle this one. So the oxidized one is this one because it's losing an electron. You can sit here and memorize reduced means that you're gaining electrons, but I think I'd rather have you just use your logic to get through it. So when you gain an electron, you're getting more negative, which means your positivity is reduced. Oh, that's the one that's reduced. Oxidized is the other guy. So that way you don't have to sit and memorize anything. You can just sort of think your way through it. Okay, so here's just a general way that you can draw it. Here's substance X and it's got an electron. It gives that electron to Y. So Y is gaining the electron, which means it's getting more negative, which means that it's getting less positive. So its positivity is reduced. Y is getting reduced. Substance X is the opposite one. It must be getting oxidized. It's lost the electron. Okay, so here's the part that you are going to love. If you have something getting oxidized, something else is getting reduced, right? They always go together. And so this one, it's getting oxidized, but that means what has it done to the other guy? It's reduced the other guy. So we call it the reducing agent. Fun, right? And this one is getting reduced, right? But what has it done to the other guy? Well, it's oxidized it. So we call it the oxidizing agent. Don't you love that? I told you you're going to love that. So maybe replay that little part of the video 15 times and then you can move on with me. All right. Here's a picture. I wish I had a picture of me when I was a kid. I was not this cute, but I was the little sister. So I was the fourth kid, and my poor older sister was always like, she always had to kind of take me with her, you know? Like my sister would be going out to do whatever, and I'd be like, I want to go too. Kind of not even kidding. And my mother would be like, you know, Katrina, go read her story or go do something nice to your little sister. So here's me looking sad. So here's the story. We care about the electrons, but the electrons come with hydrogens a lot. So electrons are often transferred from one molecule to the other in the type of a hydrogen, in the company of a hydrogen ion. So it's sort of like a little sister, and it's like, okay, you can come too. So here's what I mean. If you look at if you look at a hydrogen atom, you might not know the periodic table super well, but hopefully you remember that hydrogen is that first one up there. It's got the number 1 next to it, right? It's got 1 proton, that's it. And it's got 1 electron, right? And so the hydrogen atom has 1 proton and 1 electron. Okay, if I'm thinking about electrons, that's great. But if I'm moving a hydrogen atom, I'm moving an electron. And I know there's a positive with it, and so you're not really getting as less, like if you get the whole hydrogen atom, your charge isn't actually changing because you've got a plus and a minus, right? But forget about the plus. It's just the little sister. No one cares. Think about if you're a molecule and you've just gotten a hydrogen atom, meaning the whole thing here, right? You've got the electron, which means you've got a negative, which means you're less positive, which means you're reduced, right? And I know you're not because you've got the plus, so your charge hasn't really changed, but we're still going to call it reduced because we don't really care about the protons so much. We care about the electrons. The electrons are the things that are carrying the energy. So if you take this hydrogen atom apart, right, the hydrogen atom is really made out of a hydrogen ion plus an electron. Does that make sense? The hydrogen atom is made out of both a proton and an electron. So you've got the electron, that's this guy in red right here, and then you've got the proton, but the proton is really just a hydrogen ion, right? If you lose that electron, you're just a proton, right? Your electron's gone away. All you have left is a proton. So a hydrogen ion and a proton are actually the same thing. And make sure you have that clear in your head because we talk about protons and hydrogen ions interchangeably because they are the same exact thing. All right, so again, if you have a hydrogen atom, hydrogen atom is made out of hi David, an electron, 10 minutes, okay, an electron and a proton. The proton is really a hydrogen ion all by itself, and the electron's an electron. Okay, so if you're moving a hydrogen atom, you're moving a proton and an electron. And remember the proton, I can also call it a hydrogen ion. So here's a hydrogen atom. It's got a proton and an electron, and it's made out of, both the hydrogen ion and the electron. Okay, so now let's look at this. If you've lost an electron and this one gains an electron, it might be that this one is actually losing a hydrogen atom and this one's gaining a hydrogen atom, in which case it's gained both a proton and an electron, but we're really only following the electrons when we're talking about oxidation and reduction. Okay, so we are finally at cellular respiration. Let's take a look at this. Here's glucose and here's oxygen, right? And so here's glucose, and you can see between here and here, what's it missing? Well, to go from glucose to carbon dioxide, you've lost a whole bunch of hydrogen atoms, right? And remember, a hydrogen atom is made out of the proton, which I don't care about right this second. I will later, but I don't care about it right now. I've lost a bunch of electrons, right? So if you've lost the electrons, that's actually oxidized, right? As opposed to the oxygen, which has become water. And so if you look at this, the oxygen has actually gained hydrogen atoms. But hydrogen atoms, remember, are made out of protons, or I could call it hydrogen ion if I want, and electrons, right? And if you're gaining an electron, you're gaining an electron. So if you're gaining an electron, you're more negative, which means you're less positive. So you're getting reduced. So that means oxygen is getting reduced, right? So cool. So you ready for that? If oxygen is getting reduced, that means it's the oxidizing agent. Oh my God, right? So much fun. And so glucose, finishing it off here, is the reducing agent. Okay, maybe you're starting to see this, maybe you're not at this point, I don't know, but if oxygen is the oxidizing agent, does that kind of make sense that like the term oxidizing is because oxygen is often the oxidizing agent? So oxygen does not become oxidized. Oxygen is the thing that oxidizes other stuff. Coolio, right? And so why do I mean, oxygen doesn't have to be the thing here. Redox reactions don't always have oxygen in them. It's just that oxygen is really good at oxidation. So, oh, I just wrote this stuff here. So let's take a look at this. What is the most electronegative atom? Remember, you get more electronegative as you go this way and as you go this way. What is electronegative anyway? Electronegative, we talked about this earlier in the year, I think. Electronegative means they really, really, really love electrons. They pull electrons to themselves. They're electron hogs. They love them. Pull electrons to themselves. And so oxygen is super electronegative. And for biology, oxygen is the most electronegative atom that we see a lot in biology. So coolio, right? And so, you know, there's others like fluorine is a little bit more, but 3.5, this is all, these numbers here are electronegativity, and oxygen is the most electronegative atom except for one. And it's biologically active, like we use it a lot. Okay, so redox reactions in cellular respiration release energy in steps as organic molecules are broken down. So that is the key. It's not all lost at once. It's like these little tiny steps so we can actually capture that energy. So we break the carbon to carbon bonds in glucose, and we strip off the electrons from those carbon to hydrogen bonds by removing hydrogen atoms. And those are redox reactions.